And she is also an essential part of our TechTrek committee, and she's really a great contributor. So I've just put up here some of the things that are on today, and the most exciting ones, I think, are that we have previous TechTrekkers and also Dr. Mimi Isaac, who's the director and the driving force behind our camp, and Romy Beagle, who was a 2010 Tech Trekker, and Nayeli and Sydney, who are our new TechTrek alumni group leaders. This year we started the branch speech trek camp, and that's Hallie Schaefer is here, and we'll see her towards the end of the meeting. I really want to welcome everybody very sincerely. I want you to know that AAUW is a national organization. We have a state organization, and we are the Mar-Leucadia branch. Our committee this year working on the camp was Rebecca, who you just met, Linda Quimby, who read out our face mask responses, and Betty Reed, who's dialing in from her vacation, which is a very kind thing. So we'd never be able to do anything without them. Now, our main goal in AAUW is to support women and girls and to help move towards equity for women and girls in the workplace with the Lilly Ledbetter Fair Act, originally with the suffragettes, and with lots of other activities that we have, TechTrek, Speech Trek, scholarships for girls, lots of other things. So it just gives you a taste. It's a very vigorous organization working for equity for all. I want to introduce Romy. Romy did TechTrek in 2010, so that's 11 years ago. She's still connected with us. She's a graduate of San Dieguito High School Academy. She was the all-team president of the Paradox Robotics team. Now she's an industrial and management systems engineer, and she is with Boeing Aircraft. And I'll let Romy take over now, and I'll stop sharing so that she can share her screen and talk to you all. Are you able to share, Romy?
Yes, I am sharing right now. Hello, everyone. Get this in presentation mode. Here we go. So, hello, everyone. I'm so happy to talk with you all today. I honestly can't believe it's been 11 years since TechTrek. That time has gone by so fast. Here are some pictures of the journey, and I was sitting at my desk, and I still have my badge from TechTrek. But that's me going from middle schooler to high schooler in robotics to college student, still doing girls in science volunteering, to me standing in front of the first airplane that I have ever managed a schedule for. That is also the first airplane that has a full body decal paint. So all those colors you're seeing is a giant sticker. And it was an experiment that Boeing did to see if that's a way that we could add more color to airplanes. So me and my job, I am an industrial and management systems engineer. It's a lot of words, but I basically break that down to I am a professional engineering process improver, and I am going to walk you all through the process I go through every day. I think it's a process that can be applied to any industry, but the industry I work in right now is for Boeing airplanes. I work at the Everett site where we make all of the wide body airplanes. So any airplane that has 3 aisles in it, or I guess 3 rows, 3 sets of seats and the 2 aisles, those are all made at the Everett factory, which is the largest building in the world by volume. It's pretty cool. I don't work in that building. I work right next to it at the pretty building you see in the top picture, which is the delivery center. So once we're done building a plane, we have to test it. We fuel it for the first time. We run its engines for the first time. We make sure all of the software and electrical systems are working. We'll do its first test flight. And then customers from all around the world will come to our site and look at their airplane, make sure it's up to their standards. They get to do a test flight on it as well with their own pilots. And then we say that the airplane can't be changed anymore. There's paperwork signed off. There's a lot of money exchanged. The airplane is delivered to the customers and they fly it away from a little airport called Painfield that I live about 10 minutes away from. So I am hearing these jumbo jets take off all the time, and I get to work on that incredible live airport that you see there. So I'm usually toward the north side because that's where the 87 program is. You've heard of the Dreamliner airplane. It's something that if you've ever been on an international flight, a lot of those are used on. Gorgeous airplane, privileged to work on. And yeah, I wanna show you all the problem solving process that I go through. I think it's something that you can definitely grasp. So first, what is a problem? Problem definition is the basis of any good engineering problem solving. Our problem is the gap between our current state, so what's happening now, and our ideal state, what we'd like to have happen. So does anyone want to come off of mute and give us a problem to solve during this presentation?
Global warming.
Global warming, that's a big one, but we can use it as an example. That, what you just shouted out, is an example of an anecdotal problem. It was the first thing on your head, but how I find problems at work is a little bit more data-based. Now we have a lot of data to support global warming, and that's a great way to find problems because you know that it's an issue if there's data to support it. Most often in my job, we expect certain tests on the airplane to require a certain number of people or a certain number of hours to complete. And when we see it needing a lot more hours or a lot more people, we know there's an issue. We can also talk with mechanics. If there's something, they're doing the work on the airplane every day, they're frustrated. And we can also see it by observing the process. So in the case of global warming, the best way to spot that problem is probably data, because anecdotal evidence, some places it's hot, some places it's cold. Observing the process, it's such a gradual thing over time, you may not see it as clearly as I would if I just watched a mechanic complete a job and noticed that he was using the wrong tools. So that's why it's really important that you have different ways to find and document problems. Our next item. Now we've identified a problem, we have to find its root cause. So an easier way to find the root cause is to act like a 5-year-old and do the 5 whys method. So we just ask why multiple times. So we can try that with our global warming question. So why is there global warming? You shouted out a big problem. Okay.
There's global warming because the leaders aren't acknowledging it, so they're not like willing to stop it.
Why aren't they acknowledging it or willing to stop it?
Because then they'll lose money.
Why is them losing money a driver?
Because they don't want to lose money, and because if they acknowledge it, because their factories, they create things that do create global warming. So if they do say this is a problem, then they have to stop making it.
And why would that be a problem? And you don't have to keep answering, but we see how as we ask why and why, the answers get more complicated and more difficult to solve. But if we get to the root of that why and we can address that base issue, then all of the whys that came before it kind of collapse and we've solved the problem. Now, global warming is something that could probably be better served by the fishbone method of root cause analysis because it acknowledges a lot more complexity. So in the fishbone, we have our problem statement here. So we have global warming, and we have 6 different categories of things that could be causing that problem. Man, machines, methods, so how we do things, measurement, how we're measuring stuff, materials, and Mother Nature. Now, for each of those sections, we'll break out whys and where there are little issues. So, man, we're consuming a lot of stuff that's not good for the environment. That's on us. Machine, we have a lot of machines that are putting out pollutants. Methods, well, we're trying to solve global warming in a lot of different ways, but are those methods effective enough? Are they catching up? And are the ways that we are living our lives, is that going to help? Measurement, are the tools that we are using to measure global warming capturing the changes accurately? Or are our temperature readings not good enough? Materials, there are a lot of materials that we use in our world that can contribute to global warming, like concrete is going to cause more heat than grass. And Mother Nature. In this case, Mother Nature is going to run her course with or without us, but I don't think she's really to blame here. In a situation that I would encounter at work, something that's a big problem is having to strip and repaint airplanes because of small defects. So there we can kind of blame Mother Nature because in the summer, we have to keep the hangar doors open and it gets hot and bugs come in. And if a bug gets stuck to the airplane, it creates a little bump that customers don't like and we'll have to remove it. We could also have an issue with the paint material itself. We can have an issue with the scale that we use to measure the thickness of the paint. We could have an issue with the mechanic. It's pretty common that mechanics, because of the awkward angles you have to be at to paint an airplane, get shoulder injuries. It could be something happened with the paint sprayer, or it could be the way that we're applying paint that may have caused an issue that we'd have to redo the work. Now, this is the part that people usually think of as engineering, but the first 2 steps I think are the most important. This is where you get to have solutions. Now, the type of solution that you come up with and the type of engineer that you work with completely depends on the root cause. So if I'm at work and I'm working, something's wrong with the paint chemicals, I'll work with a chemical engineer. If there's an electrical problem, I'll work with an electrical engineer. If there's something wrong with the job write-up, I'll work with a manufacturing engineer. In your case, with the problem of global warming, you're going to work with environmental engineers and to get together and create a bunch of solutions that address specifically the root cause. Step 4, we implement our solutions and we check if they worked. This is part of the reason that our problem statement is so important, because we need a good baseline to compare against what we've done now. So we tell if it worked the same way we identified it in the first place. With global warming, we've put a lot of solutions into place already, maybe not on the scale that we could be, but our data analytics, if we look at the data, we can see that the solutions that we've implemented haven't impacted the rising global temperatures enough to say that the problem is really solved. In my work scenario, I would look at data on, again, those job times and people requirements. If they're not going down, something's amiss. But if I talk with a mechanic and they're happier with the process, they're feeling ergonomically better, if I observe the process and I see it's more standard and flowing more smoothly, I can see that maybe we have made a positive difference.